Welcome student to Praveen Patil College of Diploma Engineering and Technology. Chapter number 2, Derivative. Quotient rule, it is important, that is derivative of f of x upon g of x. That's all we have to study in derivative. Before going to that, what is exactly derivative? Differential calculus is the study of rate of change of the function. The derivative of the function f at x is equal to a is defined to be limit h tends to 0 f in bracket a plus h minus f of a upon h, provided the limit exists. In the previous chapter, the slope of the curve at x is equal to a. Now we have specific name for this limit. Will expand to use include a broader spectrum of the application. In the derivative, it is the increasing function. We have to must focus about that function, and f in bracket a plus h, f in bracket a upon h, that is important. Notation for Newtonian notation, that is f dash of x, y dash of x and y dash. The dash is Newtonian notation. Leibniz notation is dy by dx, d upon dx of f of x and df upon dx. That is the notation which most probably Leibnizian notation we have to most probably use. We have to remind the formula, derivative rules, exponential function. Derivative of e raised to x is e raised to x. Derivative of a raised to x is a raised to x log a. Derivative of e raised to g of x is e raised to g of x into g dash of x. It is called also chain rule. Derivative of a raised to g of x is ln, means log a raised to g of x into g dash of x. Logarithmic function, derivative of log x is 1 upon x where x greater than 0, that means it is positive. Derivative of ln of g of x is g dash of x, means the derivative of g upon gx, the function given in a bracket. Derivative of log x to the base a is equal to 1 upon x ln a, that is x greater than 0. Now derivative of log to the base a of g of x is equal to g dash of x upon g of x ln a, means derivative of g of x into upon g of x into log a. This most probably, this portion, it is obviously called the chain rule. Now trigonometric function, derivative of sin x is cos x, derivative of cos x is minus sin x, derivative of tan x is sec square of x, derivative of cosec x is minus cosec x into cot x, derivative of sec x is sec x into tan x, derivative of cot x is minus cosec square of x. These are the trigonometric function which most probably use inverse trigonometric function. Derivative of sin inverse x is 1 upon under root 1 minus x square, where x not equal to plus minus 1. Be careful, the term or number, it is always greater than 1. Derivative of cos inverse of x is equal to minus 1 upon under root 1 minus x square, x not equal to plus minus 1, that is x greater than 1. Derivative of tan inverse x, 1 upon 1 plus x square. Derivative of cot inverse x minus 1 upon 1 plus x square. Derivative of sec inverse of x, 1 upon x under root x square minus 1. X not equal to 1 plus minus 1 or 0, because 0 into anything remain 0. Derivative of cosec inverse of x is minus 1 upon x under root x square minus 1. X not equal to plus minus 1 or it is not equal to 0. Hyperbolic function, most probably denoted by the sin h is there. In the previous, here the sin x is there, x term is there. Here in this next slide, we have to take the sin x, that is hyperbolic function. Sin x is cosec x, cosec x is sin x, derivative of tan x is sec x square of x, derivative of cosec x that is the cosec x into cot x. Derivative of sec x is minus sec x into tan x. Derivative of cot x is equal to cosec x. That is inverse hyperbolic function. Derivative of sin x inverse x is equal to 1 upon under root 1 plus x square. Derivative of cosec inverse of x is 1 upon under root x square minus 1. Derivative of tan x inverse x is 1 upon 1 minus x square. Derivative of cosec inverse of x minus 1 upon x under root 1 minus x square. Derivative of secant inverse of x is minus 1 upon x under root 1 minus x square. Derivative of cosec inverse of x is 1 upon 1 minus x square. Be careful here, x not equal to 0, here 0 less than x less than 1 and x greater than 0. Most probably positive terms we have to consider in derivative. This is the revised term of the derivative. Now we have to focus our first rule. If y is equal to u into v, that is the function have the multiplication where u and v are different function of x, then derivative of y with respect to x, that is y is u into v, u derivative of v plus v derivative of u. Find the derivative of y is equal to e raised to x into tan x. We have the derivative formula dy by dx is equal to derivative of u into v, u derivative of v plus v derivative of u. Here e raised to x is there and tan x is there. E raised to x is derivative of tan x is obviously sec square of x. Tan x derivative of e raised to x is e raised to x. We have to substitute the derivative of tan x and e raised to x. So we simplify dy by dx is equal to, we have to take e raised to x common, sec square of x plus tan x. If y is equal to sin x into cos x, find dy by dx. We have y is equal to sin x into cos 2x. dy by dx is equal to sin x, derivative of cos x is minus sin 2x into 2 plus cos 2x into derivative of sin x is obviously cos x. Minus 2 sin x into sin 2x plus cos x 2x into cos x. Again now we have to define the quotient rule which is very important. Let u is equal to f of x and v is equal to g of x. Then quotient rule is defined. Derivative of u upon v, v derivative of u minus u derivative of v upon v square. Here u is e raised to x, v is x square. We have to put in this formula. We derive derivative of e raised to x into x square minus e raised to x into derivative of x square upon denominator whole bracket square. So x square raised to 2. E raised to x into x square minus e raised to x into derivative of x square is 2x. Therefore x raised to 4. We have to take suppose e raised to x common. We derive x is common. Then we have to take the x minus 2 is there. X get cancelled with x raised to 4. So we remain as e raised to x in bracket x minus 2 upon x cube. Next, derivative of tan x. Now we have to suppose we have to equivalent the derivative of tan x is sec square of x. We know that we have to just verify using the quotient rule. U is equal to f of x and v is equal to g of x. Then derivative of u upon v, v derivative of u dx minus u derivative of v dx upon v square. We have derivative of sin x, derivative of cos x, that is derivative of sin x cos x remain as the same, minus sin x derivative of cos x upon cos x whole bracket square. So we know that derivative of sin x is cos x into cos x cos square x. Sin x remain as the same. Derivative of cos x is minus sin x, that is minus minus become plus. Cos square x plus sin square x is 1 by fundamental trigonometry identity. 1 upon cos square x is sec square x, that is derivative of tan x is sec square x by using the quotient rule of derivative. Now x square upon 2 plus x dash is given, that is we have to find the derivative of x square upon 2 plus x. We define that numerator function is different, denominator function is different. So why we have u f of x is and v g of x, then derivative of u upon v is v derivative of u minus u derivative of v upon v square. So x square is u, 2 plus x is v. We have to put x square derivative 2 plus x v, that is minus x square 2x dash. Dash included the in Newtonian notation, that is derivative. So x square derivative is 2x plus 2 plus x remain as the same. X square remain as the same. 2's derivative is 0. X derivative is 1. 2x plus x bracket square. We have to simplify 2x into 2, 4x, 2x into x, 2x square into 0, 0, and x square into 1, x square. We have to 2x square minus x square, it is the x square, plus 4x upon 2x plus x whole bracket square. Derivative of y is equal to sin x upon x raised to 4, where u is f of x is sin x, v is g of x is x raised to 4, then derivative of u upon v is v derivative of u minus u derivative of v upon v square. Here u is sin x, v is x raised to 4, so x raised to 4 remain as the same. Derivative of sin x minus sin x derivative of v, that is obviously x raised to 4 upon x raised to 4 whole bracket square. X raised to 4, what is the derivative of sin x? Cos x. Sin x remain as the same. What is the derivative of x raised to 4? We have to know that x raised to n, derivative of x raised to n and x raised to n minus 1. That's why 4 goes to multiplication. X raised to 4 minus 1 is 3. So derivative of x raised to 4, 4x cube. We have to simplify. We have to take the x cube common. X cos x minus 4 sin x upon x raised to 8. X cube and 1 x raised to 8, here 5 is remaining. So obviously x cos x minus 4 sin x upon x raised to 5. It is the final answer of y is equal to sin x upon x raised to 4. Quotient rule is very important. F of x and g of x are differentiable, then derivative of f of x upon g of x f dash of x minus f of x into g of x upon g of x bracket square, u f of x and v g of x, then derivative of u upon v derivative of u upon x minus u derivative of v upon x and v square. Constant multiple rule, which is very important, we have to must take care. The constant multiple rule, if c is the constant, f is differential function, then derivative of c in bracket f of x, c derivative of f of x. Basic differentiation formula: derivative of constant is always 0, derivative of x is 1, derivative of kx upon dx is k, because derivative of x is obviously 1, derivative of x raised to n is n x raised to n minus 1. This differentiation formula we have to use the examples. So differentiation rule we have to discuss in today's lecture. Constant rule, derivative of any constant number is always 0. Power rule, derivative of x raised to n is n x raised to n minus 1. Product rule, derivative of f of x into g of x is f dash of x into g of x plus f of x into g dash of x. Quotient rule, derivative of f of x upon g of x is g of x into f dash of x minus f of x into g of dash of x upon g of x whole bracket square. Chain rule, derivative of f in bracket g of x is equal to f dash of g of x into g dash of x. These are the differentiation rule which are most probably used in the example in the board pattern. Take the exponent and multiply it by the coefficient and decrease the exponent by 1. Means what? We have to suppose 5 f of x is equal to 3 raised into x raised to 5. We have to apply x raised to n. Derivative of x raised to n is n x raised to n minus 1. That's why derivative of x raised to 5 is 5x raised to 4. 5 into 3, 15. So we derive the format. Now we have to take the example. Derivative of 3x raised to 4. 3 constant remain as the same. Derivative of x raised to 4 is 4x cube. 4 into 3, 12x cube. Derivative of negative. Negative remain as the outside the derivative x. X derivative is 1. Minus 1 into 1. Final answer is minus 1. Next, y is equal to x square plus x minus 2 x cube plus 6. We have to apply the derivative u upon v rule. V derivative of u minus u derivative of v upon v square. So we have to apply the y dash, means it is the derivative x cube plus 6 derivative of x square plus x minus 2 minus, we have to put bracket if it is necessary, x square plus x minus 2, derivative of x cube plus 6 upon x cube plus 6 whole bracket square, x cube plus 6 remain as the same, derivative of x square 2x,